if we had had this conversation about a year ago, my answers would have been totally different. This is an ever-changing market. It's constantly evolving. And so having conversations like this, continually learning and understanding what's going on in the market is really going to be crucial to getting this market to continue to move forward.
Hi, I'm Jacob Susman, and welcome to the Great Green Upgrade. Today, I'll be talking to Megan Reusser, Hydrogen Technology Manager at Burns McDonnell. Megan is an expert on the technical aspects of green hydrogen project development. Welcome, Megan.
Thanks, Jake. I'm glad to be here.
Well, it's good to have you. Maybe we can start off with your background and how did you end up as the hydrogen guru at Burns and Mac?
Sure. So I've been in the industry for about 14 years now. I graduated from the University of Kansas with a bachelor's in chemical engineering. So I started doing process engineering for oil and gas projects right out of school and focusing specifically on liquefied natural gas. So I did that for about 10 years. And then about 4 years ago, I switched over into the power industry and focusing on energy markets instead. And that was actually about the time that we started seeing, large efforts for decarbonization in this energy transition. So there was really a need to fill the gap with decarbonized fuels. And my oil and gas background combined with an energy background really was a great match to get into focusing on hydrogen-related projects. So I've been doing that for about 4 years now, specifically looking at green hydrogen production with electrolysis and how that can be produced, transported, and utilized.
What an awesome background for this exact topic. We find that there's a lot of people who've come to the sector from the renewable power world, or people who come to the sector, more from the pipes world, if you will. Relatively few people have that nice balance of both. So that's awesome.
Well, by no means do I pretend to be an electrical engineer. So,
and I think we're both well aware that the green hydrogen sector has, let's say, been a little slow to really take off as fast as we would all like. What do you think it'll take to really get the flywheel going for green hydrogen? So we're just pumping out projects left and right, hopefully in relatively short order.
Well, I think, as we all are aware, we've got the 45V production tax credit, and there is a little bit of uncertainty about the final rulings for some of that, specifically around the time matching and additionality clauses. So I think once that there's final ruling and more clarity on those specifically, we will see more traction here in the United States. But did want to add that we're seeing a lot of interest outside of the U.S., so specifically in Canada, which has its own rules and regulations. And so the 45V and the production tax credit isn't necessarily, it's not applied there. And so those projects specifically on East Coast, where there's a lot of offshore wind or wind development projects, still seeing a lot of traction there.
Megan, that's super to hear about all the traction you're seeing in other markets. Tell us more specifics about the kinds of projects you're working on there or that you've seen kind of come to market.
Sure. So if we kind of look at the Canadian market as a whole, there's kind of two categories, similar to probably what we would see in the US, but we've got, the more traditional oil and gas markets, especially if you look at the oil sands projects more in the Alberta area. Those are more likely going to be blue hydrogen related projects. Canada does have some more strict regulations about CO2 emissions, and they're going to continue to get more and more strict with more penalties for producing CO2. So the projects that are already producing hydrogen, specifically gray hydrogen, are likely going to use carbon capture to create blue hydrogen. However, on the other side of the geography, somewhere on the East Coast, there is a lot of wind development happening. And so that's where we're seeing more interest in green hydrogen production. And those can be upwards of 100 megawatts, 200 megawatts, 300 megawatt projects. So there's definitely a lot of interest there. And some of that could be for utilizing in a nearby use case as well as transporting to other parts of the country.
That's really interesting. And the fact that those projects are moving ahead tells me that there is some stronger driver in Canada than we have here. I think I heard you mention that that's more of a compliance driver or a regulatory driver that says you got to reduce your CO2. Is that what you think is kind of like helping get all that traction?
So I hear people use this analogy quite a lot is, in the US, it's more of the carrot of getting the production tax credit, and in Canada, it's more of the stick. Mm-hmm. So it's more of a penalty that you have to avoid. So I can't remember the exact number because it's changing pretty frequently, but for every metric ton of CO2 that's produced, there's additional penalties that you have to pay. And so utilizing hydrogen as a way to decarbonize some of those industries can help to minimize those penalties for CO2 emissions in Canada.
I gotcha. Yeah, it's been interesting. Some of the most exciting opportunities we're pursuing now are also in similar compliance markets, typically outside the U.S., and a lot of them are pointed at e-fuels, for example, where in Europe they've said, shipping industry, aviation industry, steel industry, cement industry, thou shalt lower your carbon by a certain amount. And boy, does that motivate people to go out looking for solutions in order to plug that gap.
For sure. A lot of the projects we're seeing, the end use is not necessarily just the hydrogen, but it's also to produce some of those derivatives, specifically ammonia.
Mm-hmm. And so drilling down a little bit to just the green hydrogen projects that you're involved in, what's been the typical style of project you're seeing? Is it more kind of behind the fence for a customer's bespoke situation? Is it more the classic kind of field of dreams approach? Build it and they will come. Tell us about typical size ranges. Who are some of the typical end use customers? Just give us a little more of a feel for what the style of those projects are, please.
If we had had this conversation about a year ago, my answer might be totally different. With the changes and uncertainty with the 45V, I think some of the projects have kind of changed that we were seeing. For example, there have been some projects that were potentially going to utilize nuclear power to produce hydrogen. And with the changes to 45V, which include the additionality, some of those projects have been put on hold or potentially not moving forward. However, when we were looking at certain projects where they were already going to build new renewables to support that, whether that is behind the meter or a new type of development, those are still moving forward in the sense that the 45V hasn't really changed their business plan because they were going to build renewables anyway. And so now they just need to account for the time matching. And so those are the ones that we're seeing. And potentially those are where they're not necessarily utilizing the hydrogen themselves. They're more selling it to another customer that's planning to use the hydrogen.
Interesting. Okay, got it. And that sounds like a reference more to the field of dreams approach. Are you seeing some of these examples where industrials or manufacturers, just are thinking about having an electrolyzer on their property or right next to it?
So we had seen some of that, but it became more challenging with the fact that, a lot of these, if they are existing facilities, don't necessarily have the renewable power to make the green hydrogen. Mm-hmm. Or specifically, as I mentioned, I work in our energy and power markets. We were seeing a lot of interest in utilizing hydrogen in a power generation application. So replacing natural gas with hydrogen in a combined cycle or simple cycle application to produce power. So it became challenging to have an electrolyzer on site that needed power to make power. And so that would be more of the application where they would be looking to just purchase the hydrogen from someone else or have it delivered via pipeline. So I guess to answer your question, more of what we're seeing is people developing hydrogen projects to sell hydrogen, not necessarily developing their own hydrogen.
I follow you. Yeah. And by the way, we totally agree that the time when we'll see a 7FA style turbine or a CCGT built that's designed to run 100% on green hydrogen is still many years in the future. We've got some time until that happens.
Right, because even if the turbine is capable of doing that, it really comes down to the supply question. Where's that coming from?
Yeah, that would require a heck of a lot of wind and solar to get built, which in our opinion would be a good thing.
Yeah, for sure.
But so maybe pull back the frame a little bit. So when you're running through some of these design engineering exercises, what are some of the key challenges? Geek out with us a little bit and tell us some of the really thorny issues that you'd seem to run into from time to time or consistently.
So the first questions I always ask everybody when we start looking at these green hydrogen projects they're pretty basic, but sometimes they're crucial. Do you have power, and do you have water? We've seen a lot of projects where it's a renewable developer, they've got lots of power, but it's in the middle of the desert. So it's great, we want to develop hydrogen projects, but hydrogen projects do require water. And if you're in a location where that's a scarcity, that could definitely limit the availability of developing that project there. I sometimes make a joke, if you want to geek out. I was joking about hydrogen's water problem. And so I said it was H2O no.
We had a round of dad jokes going around internally this morning. I think I might put that on the dad jokes list if that's okay.
Okay, I'll accept that.
Water's definitely a challenge, and then maybe I'd be curious about any specific construction challenges. I'm thinking back to my wind energy days where if your soils weren't up to a certain quality, or you could have wetlands issues in the area. It doesn't necessarily mean that the project doesn't work, but you might have to, sort of backfill with all kinds of new additional CapEx. Do you run into anything like that, or, kind of on the ground considerations for the actual construction of the projects that can create challenges?
So I think that everything that you just described is definitely something that could be a potential challenge for a hydrogen project. However, I don't necessarily know if those are unique to hydrogen projects. That could really just be any type of industrial project where your soils aren't what they need to be for whatever structures or equipment you're putting on the site. And again, not necessarily unique to a hydrogen project, but labor can become a huge challenge, specifically when there's a lot of projects that are trying to be developed at the same time. And so that's actually one of the first things that we can look at on a project is, where are we trying to develop this project? What is the labor availability? What does the labor market look like? And if there are a lot of projects happening in the same geographic area at the same time, resources can become challenging. And that can also increase the capital cost of a project, because to attract that labor and attract that talent may have to offer incentives or higher wage rates in order to get the talent and labor that you need for your project.
Yeah, we're hearing a lot about labor challenges that can affect lead times. We're also hearing, about the typical transformer topics, general electrical topics, compressors maybe. So, what else are you seeing could cause some? By the way, we're not hearing as much about electrolyzer lead time challenges. So, and tell us about lead times and what are the real pressure points.
So I would say that a lot of times, because it's a hydrogen project, everybody wants to focus on the electrolyzer. That's the one that makes sense. Like, that's going to be the long lead item. But then when you start actually building out your schedule and you start actually talking to vendors and getting lead times, we realize that sometimes, it's not the obvious pieces. It's not the electrolyzer. It's the electrical equipment. Some of, if you want to call it kind of, standard stuff that you weren't even necessarily thinking about. I'm not sure if it's getting better recently, but on some of this transformers, we're seeing 100 weeks lead times.
Whoa. Okay. Good to know.
And it can definitely be a challenge, especially when, the electrolyzer is less than that. That's when you're wanting to get your project online, but now you're waiting for something to actually connect it to.
Yeah. And interestingly, when you're designing an electrolyzer facility, again, just thinking back to my own experience in wind and solar, Much more of it is down to the specific configuration that you choose, as opposed to just, standing up a wind turbine or building the erector set under a solar panel. Talk about some of the menu of options that are available when you're doing that design work. How much compression, how much storage, do I want to use solid oxide or PEM or alkaline? What are kind of the 2 or 3 major decisions that you have to make when you're when you're optimizing that design?
Sure. So aside from the 2 questions I asked is, do you have power? Do you have water? The third question would be, what's your use case? Mm-hmm. Or what are you intending to do with the hydrogen? If the intent is to produce hydrogen and store it until trucks can be brought to site and then offtake can happen, or is it being fed directly into some other process, or is it going to go into a pipeline? Understanding where the hydrogen's going and what you need to do with it can really impact what the rest of the facility is going to look like. So if you are planning to put it directly into another nearby application, that can determine how much pressure and flow that you need. And depending on what that looks like, you might not even need any storage. However, if you were planning to have trucks come and offtake your hydrogen that way, then that becomes a bigger question of how often are they coming? How frequently are you going to be able to offload that product? And so that kind of determines how much storage you need to have. And I think maybe we'll get into this more as we continue talking, but storage can really become one of the bigger challenges. I don't want to say that the electrolyzer piece or the production piece is the easy part, but I think that understanding those technologies is pretty well known at this point. But storage is a challenge, because hydrogen doesn't necessarily want to be compressed, and it doesn't necessarily want to be liquefied. And so both of those processes can be energy and capital intensive. And so there is a decision there of what to be done.
Yeah, that's a really interesting point. And building on what you mentioned about going into the neighboring facility, if you were going into somebody's existing industrial process, what are some of the factors that they have to consider? Is there a disruption to their operations? Do they have to do major CapEx in order to, take the hydrogen? What are you seeing in that realm?
That's a great question. I think that it's definitely going to be on a case-by-case basis. And I think you hit on it exactly. If you are supposed to be supplying them hydrogen and there's a disruption in your operations, how does that impact them? So that could potentially require some intermediate storage as well to make sure that there's smooth operation there. And then, kind of taking a step back in the process, which would be to look on the production side, depending on what your power source is, and again, what your use case is, there could be some selections that you need to make on the technology side for the electrolyzer. For example, a PEM type electrolyzer may be able to respond better to fluctuations in load, so it can ramp up and down more quickly than an alkaline type electrolyzer. However, an alkaline might operate on a more steady state at a base load. You can produce more hydrogen at a larger scale. So depending on what you're tying it to and the amount of hydrogen you need to produce could really drive not only what your storage is going to look like, but what your production will look like.
That's helpful. And if we can drill down even a layer deeper just on the electrolysis technologies in particular, is there a bright line between, you should use PEM for this and you should use solid oxide for that and alkaline for a third thing? I mean, I heard you say the PEM ramps up and down sort of more flexibly. The alkaline is more set it and forget it. Anything about the oxygen maybe, or about the pressure, or I don't know. You have any insights on that?
I really wish that there was a super clear answer that I could give you of this one is perfect for this and you should always do this. But in reality, it's not a great answer, but it depends. Every case is going to be a little bit different. And part of doing that early stage project development is really evaluating the specific use case and that specific project and what that's going to look like. I've definitely done a lot of deep dives into different electrolyzer technologies and what that offering looks like. And every time I do that, I'm surprised my answer is a little bit different every time because every project's going to be a little bit different.
Well, every project's different, and it's a rapidly evolving industry, and there are lots of companies, working on different challenges and coming up with new solutions. So not surprising that that things are going to change a little bit as you roll through. And in that regard, where are you seeing some of the most promising technology development? Both, maybe in the trailing couple of years, like who's come the furthest along with their tech, and then where do you see some of the most, future opportunity to improve the tech even further?
So what I've kind of seen is I keep in touch with technology suppliers pretty frequently, understanding what their offerings are, what their capabilities are. And kind of in general, what I've seen is the shift towards kind of a more standardized product. So the intent would be to have, if you want to call it an off-the-shelf offering, where this is what you get, kind of take it or leave it. And they're really focusing on optimizing around their specific core technology. And that's kind of where the challenge comes with a lot of these evaluations, is that not everyone's offering is exactly the same. For example, some suppliers may have an atmospheric electrolyzer. So the hydrogen comes out at a pretty low pressure, which then requires additional compression. Whereas other suppliers may have a higher pressure coming out. And at that case, that might be more desirable. Mm-hmm. So regardless of which specific technology or which specific supplier you're looking at, in general, I've seen a trend towards standardization and modularization, which I think is going to definitely help with the lead times of projects as well as the development as it become more standardized across the market.
Yeah, it's a really interesting point. When you first had kind of the scale up of the the solar module OEMs and the wind turbine generators, it was as much about the supply chain and then kind of the manufacturing scale up itself, and then also the delivery, also the kind of logistics of getting the equipment to the site, or in some instances doing some fabrication at the site. Are you seeing electrolyzer manufacturers in particular kind of making advancements in that broader scope? In other words, not just the tech itself, not just the R&D, but kind of the broader scale up?
So interesting that you asked, because I was just looking at a study where this kind of became a large topic of discussion, because a lot of the manufacturers that we were looking at were outside of the US. Mm-hmm. So that included Europe, but it was also Asia as well as India. And so it's kind of one of those things where if you just look at the base costs, like maybe there could be some potential savings on CapEx by going with a supplier outside of the US. However, once you kind of start factoring in the logistics and transportation to get it to the site, it kind of evens out eventually. But it's definitely one of those things that it's easy if you just look at the bottom line. You're not necessarily looking into all the details to kind of overlook and forget about. So factoring in transportation and logistics and potentially the time to get it to site is going to be important in that evaluation.
For sure. And just going back to the tech itself for a second there, we kind of look at ways that the technology providers are driving down the amount of energy that's required. So that's kind of yield is a big topic. Rare earths is a big topic, and needing less platinum, for example. And then again, also as you were pointing out, kind of more repetition, more sort of repeatable, approaches to manufacturing seems to be a third way. Let's just go over maybe to a little bit of your crystal ball. So, we're sitting here, call it 5 years from now, gearing up for or I guess we've just had the next election at that point, but we're past this one, and the 45V, terms are known, and companies have started to, run their first few projects, in green hydrogen. What do you think this market looks like 5 years from now? And what are the kind of most common applications of green hydrogen? What are the companies that are most typically having success getting projects online? And who's using the hydrogen for that matter?
So I wish that I had a super great answer for that. I would love to have a crystal ball that had all the answers for that. But ideally, late last year, the DOE did announce the winners or the selected DOE funded hubs. So there were 7 hubs that were selected to receive, on average, about $1 billion per project. And so ideally, I think it would be that those projects are moving forward and those hubs are being built, which was the intent of, sparking and getting this market going. So if you kind of look at what those hubs are doing and the types of projects that are involved in the hubs, the intent is that a lot of them are co-located. So the people that are producing hydrogen aren't necessarily the ones that want to use it, but the people that want to use it don't necessarily want to be responsible for producing it. So having the co-location of the production and utilization in a similar geographic area, I think is really going to be beneficial to getting these projects moving forward. And if you dig more into what those hubs and the types of projects that they were developing, you do see that it's a lot in the industrial or manufacturing applications. So if you want to call those the hard to abate sectors, so projects that are maybe hard to purely electrify. And there's a big push to move towards let's electrify everything. But there's a lot of industries where you can't just put a battery on an airplane and call that good, right? So seeing these hard to abate sectors utilizing hydrogen as a way to decarbonize.
Yeah, as you know, at Ambient Fuels, that's a big part of what we do is help some of those industrials and manufacturers who have those hard to abate operations, meet some of that decarbonization goal with green hydrogen. In that 5 years forward vision, do you think that'll be a good chunk of where we're seeing projects get installed? Some of those manufacturers and industrials taking green hydrogen molecules instead of natural gas?
I think so. I think I think even the DOE published a graphic of what the different industries and the adoption of hydrogen looks like. And those are some of the first early adopters of utilizing hydrogen. Where you start looking at some of the other sectors, so transportation, power generation, those are a little bit further out. Those are, maybe the 2040, 2050 timeline.
So Megan, if our listeners want to learn more about what Burns and Mac and you are doing in the sector, where can they find that information?
Sure. So I would encourage anybody that would like to learn more or specifically connect with me to find me and reach out on LinkedIn, as well as visit the Burns and Mac website. So that is burnsmcd.com.
Megan, this has been terrific. I've enjoyed the conversation. Is there a kind of a closing thought you had or anything you wanted to mention that we should let our viewers and listeners hear?
So I guess what I just want to point out, and I mentioned it early on, is that, if we had this conversation about a year ago, my answers would have been totally different. This is an ever-changing market. It's constantly evolving. And so having conversations like this, continually learning and understanding what's going on in the market is really going to be crucial to getting this market to continue to move forward.
That's awesome. Megan, thank you so much for being with us today. Enjoyed the conversation as always, and I even learned a thing or two. So great to spend this time. For more episodes, go to ambientfuels.com. Also follow us on LinkedIn for more green hydrogen news. Thanks for listening, and see you next time.